If it is in the form of f of a minus f of b, then you can write this as integral from b to a f of x dx. I have the limits x is equal to a, x is equal to 2a. So using this result, if x is equal to a, then t is also a. If x is equal to 2a, then t is equal to 0. If f of minus x is f of x, then it is even function. If f of minus x is minus f of x, then it is an odd function. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So we are here in this session studying about the properties of definite integrals. So these properties helps us to find the unique value of the given integrals, and learning this definite integral properties helps us to solve the problem very easily. So let's see the properties of definite integral. The first property is denoted as P0 or P0. So and it says integral from a to b f of x dx is equal to integral from a to b f of t dt. So here f of x dx is nothing but you are integrating with respect to x of f of x, and here you are taking function t with respect to t. So thus the independent variable here is not necessary that it has to be x always. So therefore, if the integral value of f of x dx can be written in the form of f of t dt also, f of y dy also. So therefore, the only matter is the limits and the integral function, not the variable inside the function. So therefore, the first property says, even though when you change the variable of the integration, it doesn't matter, they are one and the same. Next, this is property number 1, and it says integral from a to b f of x dx is minus b to a f of x dx. And in particular, integral with the same limits, that is where upper and lower limits are same, is 0. So let's see the proof of this integral. We know from the fundamental theorem of integral calculus, that is a to b f of x dx can be written as f of b minus f of a. Now change the order here, take minus, then it is f of a minus f of b. Now if it is in the form of f of a minus f of b, then you can write this as integral from b to a f of x dx. So this is what the property number 2 says. So suppose if you have any integral in the form of a to b, you can change the sign and you can write it in the form of b to a. And similarly, if you have both upper limits and lower limits same, then what will be the answer for this? Then it will be in the form of f of a minus f of a, which is nothing but 0. So this is the particular case. If upper limit and lower limits are same, then the integral value is 0. Next, property number 2 says integral from a to b f of x dx can be splitted into a to c f of x dx and c to b f of x dx, where c is in between a to b. So if you take a and b as a closed interval, then c belongs to the closed interval. So therefore, here the upper limits and lower limits are from a to b. Now let's see whether this is whether this verifies or not. So let me take the right hand side. So let me take integral a to c f of x dx. Use second fundamental theorem of integral calculus. What does it say? It says the value is f of c minus f of a. Similarly, take c to b f of x dx. So what is this? F of b minus f of c. Add both the integrals. Therefore, when you add this, it is a to c f of x dx plus c to b f of x dx is f of c minus f of a plus f of b minus f of c. So here f of c minus f of c get cancels. So then you will get the value f of b minus f of a. What is f of b minus f of a? This is nothing but the integral whose limits are from a to b f of x dx. So thus this property holds. Suppose when you have any integral from 0 to 2 pi, then you can write this as 0 to pi plus pi to 2 pi. Similarly, when you have from integral minus 1 to plus 1, you can write the integral in the form of minus 1 to 0 plus 0 to 1 with the same value inside the integration, but only the limit changes. Next, property number 3, if a function is from a to b f of x dx, then it can be written in the form of f of a plus b minus x, where a and b are the limits of integrals. So now let's see here. So let me take integral from a to b f of x dx. So here let t is equal to a plus b minus x. Then what is x? X can be written as a plus b minus t. Similarly, if the limits x is equal to a, then t is equal to b. Similarly, if the limit x is equal to b, then the limit t is equal to a. Now we know that we can change the variable of the function here. So put x is, so in the place of x here, you can write a plus b minus t, and in the place of dx. So if you differentiate this, what you will get? Dx is equal to minus dt. So therefore, you can change the variable of the integral so that it becomes f of x becomes f of a plus b minus t, dx becomes minus dt. I'll write outside the integral minus, and since you are taking the variable with respect to t, you have to change the limits with respect to t. So therefore, the variable changes from b to a. Now, using the property 1. So what does the property 1 says? If f is an integral from a to b f of x dx, then it can be rewritten as minus a to b f of x dx. Similarly, from right side to left side also it holds. So whenever you have negative, that is when minus of b to a, then you can write it as a to b to make it positive. So therefore, here I will write a to b f of a plus b minus t dt. So using property 1. Similarly, you can change the variable of the integration from the property 0. So therefore, here I can write a to b f of a plus b minus x dx. This is from property 0. What does it say? So if you change the variable of the integration, it doesn't alter any value. So it is one and the same. So here with respect to t is there. Now I'm just changing with respect to x. So this is what the proof for this property. Next one. P4 says integral from 0 to a f of x dx can be written as 0 to a f of a minus dx. So this is the particular case of the previous one. Whatever you have did in the previous one, the same proof you can apply here. So here put t is equal to a minus x. Then what is x? X is equal to a minus t. Then what is dx? It is minus dt. So again, when x is equal to a, t is equal to 0. And when x is equal to 0, t is equal to a. So therefore, the limits changes. Now take the function 0 to a f of x dx. Change the limits now. If x is equal to 0, t is equal to a. If x is equal to a, t is equal to 0. And f of x, x can be written as a minus t, and dx can be written as minus dt. Again, using the properties of integral, you have from a to 0, I can change to 0 to a to make it positive. We have a minus t dt. Okay, so this is using property number 1. Now again, change the variable using property 0. So then it becomes a minus x dx. So using the property 0. So thus this is the proof. Next, Property 5, that is P5 says, so when you have an integral from 0 to 2a f of x dx, you can split the integral in the form of 0 to a f of x dx plus 0 to a f of 2a minus x dx. Now here we know that if you have 0 to 2a f of x dx, I can write this in the form of 0 to a f of x dx plus a to 2a f of x dx. So using property number 2. So what does it says? That is P2 says, so when you have an integral from a to b f of x dx, you can write it in the form of a to c f of x dx plus c to b f of x dx. So this is what property 2 says, and I am using the same here. So now here the first one is from 0 to a f of x dx. It is done. I need the second one. So what I will do here, let x is equal to 2a minus t in second integral. So this is the second integral. This is the first integral. So now I have here a to 2a f of x dx. Now I need to change this variable. So now I have x is equal to 2a minus t here. Then what is t? 2a minus x. What is dx becomes minus dt. Similarly, now I have the limits x is equal to a, x is equal to 2a. So using this result, if x is equal to a, then t is also a. If x is equal to 2a, then t is equal to 0. Now change the variable with respect to t and also the limits. So now here I have, if x is equal to a, t is also a. If x is equal to 2a, t is 0. Now here I am changing x as 2a minus t, and here it becomes minus dt. So now here I have minus integral a to 0. So to make it positive, I have here a to 2a f of x dx. So to make it positive, I will take it as 0 to a f of, what is the value inside function? 2a minus t dt. So this is using property 1. Next again change the variable here. So this becomes 0 to a f of 2a minus x dx. So this is using property P0. Now here substitute the value of this integral as 0 to a f of 2a minus x, 0 to a f of 2a minus x dx. So when you let me take this as equation 1. So when you substitute this value, then equation 1 implies integral from 0 to 2a f of x dx can be written as 0 to a f of x dx plus 0 to a f of 2a minus x dx. So this is property number 5 and its proof. So next is property number 6. We have 0 to 2a f of x dx is 2 times 0 to a f of x dx if f of 2a minus x is equal to f of x, and 0 if 2a minus x is equal to minus f of x. So from property number 5, so from P5, what does P5 says? 0 to 2a f of x dx can be written as 0 to a f of x dx plus 0 to a f of 2a minus x dx. So this is property number 5. Now here I have a condition. So here let me take this as equation 1. So if f of 2a minus x is equal to f of x, so then what happens to this integral? 0 to 2a f of x dx is equal to 0 to a f of x dx, and here you need to change this plus 0 to a f of x dx. So 0 to a f of x dx plus 0 to a f of x dx becomes 2 times 0 to a f of x dx. So this is done. Now again, if f of 2a minus x is equal to minus f of x, then equation 1 implies, that is 0 to 2a, integral 0 to 2a f of x dx is equal to integral 0 to a f of x dx plus integral 0 to a minus f of x dx. So if you take minus outside, it is 0 to a f of x dx minus integral 0 to a f of x dx. So both get cancels and hence the value is 0. So using the property number 5, you can prove property number 6. So next property we have here P7, that is integral minus a to a f of x dx is equal to 2 times 0 to a f of x dx if f is an even function, that is f of minus x is equal to f of x, and integral minus a to a f of x dx becomes 0 if f is an odd function, that is f of minus x is equal to minus f of x. So let me explain this, what is even function and what is odd function before solving the property. So consider cos x. So let me take f of x is equal to cos x. Change x to minus x, then it is cos of minus x. What is cos of minus x? It is cos x. So which is nothing but f of x. So even though when you change the sign of the integral, the function is one and the same. So suppose if f of x minus x is equal to f of x, then it is called as even function. So we can call cos x as an even function. Take f of x is equal to sin x. So replace it f of minus x. So what happens? Sin of minus x. What is sin of minus x? It is minus sin x. So minus sin x is nothing but minus f of x, because sin x we have taken as f of x. So when f of minus x is minus f of x, then it is called as odd function. So if f of minus x is f of x, then it is even function. If f of minus x is minus f of x, then it is an odd function. So therefore we can take as examples here, cos x is an even function, sin x is an odd function. So this is what the property says. So whenever the function is even, then the integral value is 2 times 0 to a f of x dx. When the function is odd, then the value of the integral is 0. So now let's prove this property. Now consider here minus a to a f of x dx. Now let me write this as minus a to 0 f of x dx plus 0 to a f of x dx. So this is using P2. So when you have an integral from a to b, you will write it in the form of a to c, c to b. That is what I have done here. So minus a to 0, 0 to a. Now in the first integral, okay, so consider this as the first integral and this one as the second integral. Let me consider this as equation 1. So put x is equal to minus t, then what happens here? Dx is equal to minus dt in first integral. So now what happens? Then it is minus a to 0 f of x dx. So now we need to change the limits also here. So look here, if x is equal to minus a, so if x is equal to minus a, then what happens for t? If it is minus a, then t is equal to a. Similarly, if x is equal to 0, then t is also 0. So therefore, t is also 0. So here, so what happens here? This changes to a to 0, f of minus t and dt here, minus. So we have minus a to 0. Let me change it to 0 to a, f of minus t we have. Let me change it as minus x dx. So using, so which property? P1 and P0. What does P1 change? We can change the sign of an integral by interchanging the limits, and property 0 says we can interchange the variable so that they are one and the same. So next, so here from 1 implies, what does 1 implies? Minus a to a f of x dx is equal to, now minus a to 0 f of x dx, we got it as 0 to a f of minus x dx, and second integral is 0 to a f of x dx. So this is what we got. So let me take this as equation 2. So now what does the property says? If f of minus x is f of x. So if f of x is minus x. So here if f of minus x is f of x, what happens? So if f is even, f of minus x is equal to f of x. So then what happens to this integral? Minus a to a f of x dx is equal to 0 to a f of x dx plus 0 to a f of x dx. So 0 to a f of x dx, 0 to a f of x dx becomes 2 times 0 to a f of x dx. So this is what the first statement says. So whenever f is even, this is what we get. Minus a to a f of x dx becomes 2 times 0 to a f of x dx. Now, so let me take equation 2 again. We have minus a to a f of x dx is equal to 0 to a f of minus x dx plus 0 to a f of x dx. So this we have taken as equation 2. Now again from the property there, so if f of minus x is equal to minus f of x. So let me change f of minus x as minus f of x. If I change it as minus f of x, then it is 0 to a f of x dx plus 0 to a f of x dx. So both the functions cancel, so the value is 0. That is integral minus a to a f of x dx is equal to 0 if f is odd. So thus this is the proof for the given property. So let's see the property once again, that if f is an integral from minus a to a f of x dx, then it is 2 times 0 to a f of x dx. If f is an even function, then it is f of minus x is equal to f of x, and it becomes 0 if f is an odd function. So these are the properties of definite integrals, and the proof of the properties are also very important. Why? Because for your examination, it's a 6-mark question category. It comes under 6 marks under questions. So here, along with this property, they'll ask you any one sum using the properties of definite integral. You have to solve or evaluate that integral. So to prove the property of these definite integrals carries 5 marks, and for solving one definite integral problem carries 1 mark. So it may be in the form of 5 plus 1 sometimes and 4 plus 2. If the proof is very small, then 2 marks will be awarded for the problem. But these properties are very easy and compulsory for your 6-mark question in your examination. So we will try to evaluate the definite integral using the properties in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.